So, hello. Yes, I'm Alexandra Spalato. I'm developer relation engineer at Storyblock. I'm French, as you can perhaps hear by my accent. I'm half Spanish and I live in Madrid. It's my first time in Krakow, so I'm super happy. It's beautiful. Unfortunately, I don't speak Polish. So today my topic is how Remix is embracing web standards to redefine modern web development. First off, who is developer here? Because I know there is a lot of designers. Okay, good. And who has already used Remix? Okay, and who doesn't know anything about Remix? Okay, so first, let's dive into the evolution of web development. Web development is all about transforming data into HTML and delivering it to the browser for rendering. But let's take a trip down memory lane. Remember when web development was all about server-side rendering? You made a request to the server, the page would be rendered using a templating language and sent back to the browser. JavaScript was a cherry on top, just used sparingly to have a dash of interactivity. But then, like a plot twist in a movie, JavaScript framework like React, Vue, Angular, Svelte, and Meta frameworks, Nuxt, Next, Gatsby, and others came into the scene. And with them, the concept of universal JavaScript was born. This is like the superhero version of JavaScript. It can run in the browser and in the server. All right, so let's talk about the elephant in the room, the challenges we face in modern web development. Scalability. Our apps always need more user, more data, more complexity without crashing. New frameworks are popping up every week. It's like a fashion trend. So keeping with the latest and the greatest can be exhausting and time-consuming. Performance, nobody likes a slow website. Browser compatibility, our apps need to run seamlessly across all browsers. UI and UX, this is about our users. Developer experience, this is about us developers. We want our apps to be powerful, but also intuitive and enjoyable to use. Security, we need to keep our users' data secure, and more. Okay, I'm not here to talk only about problems. I'm here to talk about solutions, and this is where Remix comes in. So what's Remix all about? Imagine that React and the server-rendered framework had a baby. This is Remix. It has the scalability of a chameleon. It can handle complex applications, but it can scale down to the point where you don't even need JavaScript on the page. And the best part, it's built on web standards. So it's like speaking the browser's native language. It has a server-client model, so you can filter the data from the server and only deliver the necessary data to your user, enhancing your app's speed and scalability. It's built on web standards, so it's like a universal adapter working seamlessly across different browsers. JavaScript is used for user experience. It's like the icing on the cake. It enhances the user experience, but the app still works great without it. It avoids over-abstraction. Learning a new framework sometimes can seem like learning a new language and realize it's just spoken on a tiny island. So with Remix, you're learning the language of the web. And so as you are becoming better at Remix, you are actually becoming a better web developer. And also by sticking to web standards and best practice, it helps to keep things secure. So now let's dive into how Remix streamlines our development process with web standards. First off, Remix loves URLs. URLs are the backbone of the web, the address of every little piece of content on the internet. Remix embraces this and uses URLs to manage routing and data loading. Next up, we have the Fetch API. This is your tool for data handling. And let's talk about HTML. It's the language of the web. It's been there since the dawn of internet. Remix uses HTML to its full potential. And last but not least, we have HTTP caching. By leveraging the browser's built-in caching mechanisms, Remix can drastically improve the performance of your web application. So let's talk about URLs. In Remix, they are kind of a big deal. They're not just addresses. They're the backbone of your web architecture. Imagine a URL as a path, and each segment of this path is a nested layout in your UI. And in Remix, you can collocate your UI, and data handling code is the same file. We are talking about full-stack components. Remix also optimizes your client-side navigation. It knows which layouts will persist between two URLs, so it only fetches the data for the ones that are changing. And on top of it, Remix can prefetch all resources for a page when the user is about to click a link. So next time you look at a URL, remember, in Remix, it's not just an address. It's a powerful tool that shapes your web architecture, optimizes your navigation, and streamlines your development process. Now let's dive into the Fetch API in Remix. It's like your personal postman, delivering data from the web to your app. It manages request and responses objects, your outgoing and incoming data messages. And we also have headers, which are similar to the address on an envelope. They carry additional information about the request or response, like the destination or the type of data being sent. The fetch method takes your request, delivers your response, and can be called from anywhere in your app. Loaders in Remix are functions that fetch data from the server for your components. There's the backbone of your app's data flow. And Remix adds request, response, headers, and fetch to your loader's global context. So this means you can use them anywhere in your app, just like you would in the browser. And lastly, we also have helper methods like JSON and redirect that streamlines working with the Fetch API. So with the Fetch API in Remix, handling data is as easy as sending a letter. Now let's dive into data write or mutation in Remix. The magic here is based on two web stuff: HTTP and HTML forms. Again, Remix is taking us back to the basics, but with a modern twist. When we talk about creating, deleting, or updating data, in reality, we're talking about form submission. And it's not just only for your big, complex form like the user profile edit page. Even the little like buttons are forms in disguise. The Remix form component adds some special feature to the usual HTML form. After a form submission, all the loader on the page will automatically refresh. This means that your user will have always the most up-to-date information without having to refresh manually. And with form, your page doesn't reload after submission, providing a smoother user experience. And then we can use hooks like use navigation that give us access to the pending form state. So we can build a user experience as smooth as butter. Think about loading indicators, optimistic UI, and all the good stuff. So in Remix, action functions look after form submissions, while loader functions take care of getting the data. And actions and loaders are on the server. HTTP caching is a powerful feature that can really improve the performance of your web application. It's like giving a memory to your app. Instead of constantly asking data to the server, your app can remember some of it. And this will reduce the load on your server and speed up response times for your users. So in Remix, HTTP caching is used to its full potential. But what about updates? Well, HTTP caching in Remix is smart. It knows when to update the data. And this is when cache control comes in. You can define cache control headers right in your root modules. For example, you can set max age 300 to tell the browser to keep the cached data for 300 seconds. So with HTTP caching, your web app becomes faster, your server gets less stressed, and your user stays happy. It's a win-win-win situation. In these examples, the header function is exporting an object with a cache control property. The value of this property is a string that tells the browser how to cache the response. The max age directive specifies the maximum amount of time in seconds that the fetched data is allowed to be cached. In this case, it's set to 300 seconds or 5 minutes. So this code is essentially telling the browser, hey, you can keep this response and use it for up to 5 minutes without checking back with the browsers. And you can find many other directives just by going to MDN docs, because again, this is a web standard. So now, enough talking, let's dive into some code and in an example. I don't know about you, but for me, building a global search has always been super tedious. You need to keep the data from the form in the state and then in the contents and many things, etc. And then when I learned Remix and I built a global search, I found it so easy that I built a tutorial about it. So here you have the QR code for this tutorial with all the code, and this is what we are going to explore now. So get the QR code if you want to explore it later. Okay. Okay, it's good. So this is the tutorial. And this is the small website I built for this occasion. We have 2 pages, a home page, about page, a blog with some posts, and in our post we have a header and some text and an image. And then here we have our search form. It opens in a modal, and here I type my query, I click enter, and it redirects to the search result route, and it adds the query to my URL, and it displays the results by pages and post. Okay, let's look into the code. Oh, and this is built with my favorite headless CMS, Storyblock, which has a visual editor. So here we have the page, and in the page we have only one field, the body field. And then in the post, we have a headline, an image, and a text field. So we want to search if our query is contained in the body for the page, or in the headline, or in the text for the post. Okay, so now let's look at the code. So here we have a search form, which is built with the form component. This form is inside a modal, which is built with headless UI. And then we have an action here in our root file, which is the higher parent root in Remix. And we have a search result root where we extract the query from the URL, and we call all the posts and pages, and we filter them with the query, all that in the loader, and then we display the result. So now let's take a closer look how it works. So my search form, it's done with the form component. And here, if I hover and I read, it says, form, it behaves like a normal form, except that the interaction with the server is with fetch instead of new document request. And so this is why the page is not reloading, and we have a nicer user experience. OK, it says it behaves like a normal form. But who knows who remember the behavior of a normal form? Anybody knows? OK, that's good. So we are going to see if I know how it works. So let's see what I have done here. So here I use the post method, and in my root file I have an action, and from there I get my form data from the request, and with the redirect utility I redirect to the search result page, and I pass my query to my URL. OK, am I doing right? OK, it works, but I realized that I was overcomplicating things because I totally forgot how a form works and what are these capabilities. So in reality, I don't need this post method. The form has a get method by default, but I can define an action here, and in this action I will define the URL where I want my form to be processed. OK, so this, I don't need a redirect. This will go directly to the search result, and I don't need the action. I don't need to extract it. My form is going to process it in the search result page, and it will pass my query to the URL defined in the action. OK? So much more simpler, and I don't need my action. So you see how we can overcomplicate things because we have learned React, we have learned frameworks, and we have forgot the basics of HTML. So here we are, and now if I go back here, you will see that everything still working. I hope. Yes. So next, we have here in the model part, I have set up an overlay that displays the word searching when the form is processing. So users who are on slower networks are not waiting in the void, and we'll have a nice UI with this indicator. We can put a loader or whatever. And for that, I create a state, open overlay, and so if it's open overlay, I display it. So in my form, here I use the use navigation hook. Here I initiate it with navigation equal use navigation. And in use effect, if the navigation state is not idle, it means that my form is processing. So we want to open the overlay. Otherwise, we want to close it. And then if the navigation state is loading, we will also close the model. OK, so let's see now it in action. I have console log my navigation. And I'm going to simulate a slow network, like that. And I go to the console. So now here, OK, I open my search, and you can see that the navigation state is idle. So it's not processing, not searching for the moment. So we are not seeing the searching word. I type here remix. I enter. It's now the state is loading. It's OK. I'm sorry. I think I have some bug because my overlay is depending searching, but my results are already displayed. So in fact, I see my navigation state is not going to idle. OK. So that's what this code is what I was doing. and I knew something was wrong. I was doing it differently, but I had like a stone in my shoes annoying me. And 2 weeks ago, I was giving this talk at React Rally in Salt Lake City, and fortunately, I crossed Ryan Florence, the creator of Remix, and in 5 minutes, he solved my problem. And again, I was overcomplicating things. So let me show you the right way, which is much more simpler. So right, I have to. OK, so this is the right code. So here, I instantiate here my use navigation. And then I create a constant is searching. And so it's a navigation state is not idle. And if the navigation location path name is search result, so if you are in the search result route, then I open my overlay. So, and I don't need anything more in the search form than the form. So what I was doing, because of my React instinct, I was creating a state for my open overlay, set open overlay, because we are used to use state for everything. But here we don't need it because we have this use navigation. And so that was creating the error. So now if I go back here, OK. I'm going to clean that. And voila, everything is working now. OK, so now we are going back to my slides. OK. OK, so now our form is functioning properly and is passing the query to the result page. So we need to extract it and filter the stories. So the stories are the post and the page is how we name it in Storyblock, or the unit of content. And we are going to filter it with the Storyblock Content Delivery API, which is the REST API from Storyblock. So first, we extract the query from the URL, and we do that in our loader. So loaders are acting on the server and getting the data from the server. So for that, we use the URL constructor, again a web standard, to create an object representing the URL defined by the parameters. Next, this object includes a search param property which provides utility methods to work with the query string. So we use the get method, and we get the query from there. And now we need to fetch all the stories from Storyblock, all the posts and all the pages. And for that, we use the get Storyblock API method from the React SDK from Storyblock. So here it returns all the stories with no filtering. So now we need to filter them. And for that, we use the filter query parameter to filter our stories by a specific attribute. And we use the like operation to check if a custom attribute has a value that is similar to our query. And we want to retrieve all entries that contain the query. So we add an asterisk before and after. Now, where do we want to search? In the page, we want to look into the body field, and in the post, we want to search in the headline and text fields. But by default, the filters we apply are connected by an AND operator. So in this case, we want an OR operator, so we use the -- or keyboard. So this is now the complete code for our loader. We pass our filter parameter into our request, and now it returns all the story, all the pages on the post, but filtered, only the ones that contain my query. So this is on the server. In the loader, we are in the search result route. And now in my search result component, I retrieve my stories, my filtered stories with use loader data, which is a hook from Remix. And then I filter them by component to separate the pages and the post. And then I get the data to display everything. Et voila, super simple. So, wrapping up, we've seen how using web standards in Remix make building a global search a breeze. But it's not just about making our lives as developers easier, but also about delivering a top-notch user experience. With server-side filtering, HTTP caching, and all this good stuff, we are making our app faster and more efficient. JavaScript is here to enhance the user experience. And the best part, we are doing all this while sticking to web standards, ensuring our app is robust and future-proof. It's a win-win situation for both developers and users. So now we also have a raffle. I hope you like this talk, and we have a raffle at Storyblock. If you want to win a subscription to Egghead, you can scan this code. And now it's time for questions.
Thank you, Alexandra. Thank you so much. Do you have any question? Anyone? Okay, I cannot see. I think there will be, after the presentation, you know, in the background,
okay.
Not maybe public. But thank you so much for your presentation. We took a deep dive into this topic, so thank you for sharing it with us.
And you have the slides here if you want to scan the QR code. Thank you.